Hello and welcome to our lesson on chromatography. By the end of this lesson, you should be able to explain how chromatography can be used to separate mixtures. You should also be able to calculate retention factor or ROF value. Now, how is chromatography used in fighting crime? Police use it, forensic scientists use it. You can pause the video, attempt the question, and resume when you are done. Now, police can use chromatography to match the ink used to sign a forged document to the suspect's pen. So if they suspect this is forged and they've arrested someone, what they can do is compare the chromatogram, that means the chromatography made out of this, with the chromatography or the chromatogram from the suspect's pen ink. They should have similar patterns. How does chromatography work? It's a separating technique. It's a method of separating mixture used for colored or non-colored substances that are soluble in the same solvent. So if you have, say, ink from different pens dissolved in water or another solvent, you can use chromatography to work out the different colors in the ink. All you need to do is you need chromatography paper, which represents the stationary phase, and you need a solvent, which the dye you want to find out or do something about is soluble in, because the liquid, the solvent, represents the mobile phase. What does that mean? So in this case, let's use this example. You have the chromatography paper, it is the stationary phase. You have the mobile phase, which is propanol. This dye is soluble in propanol. So as propanol is moving up the paper by capillary action, it pulls or carries the dye along. So if the dye is very soluble in propanol, it will move very far and fast up the paper. If you have another dye that is not very soluble in ethanol, it moves up or is deposited somewhere towards the bottom or near the middle. In that way, you can see a clear pattern between the more soluble and the less soluble one. So the substances in the mixture are separated as more soluble substances travel up the paper faster. Now, what can we get, or what can we use it for? What's chromatography used for? Paper chromatography in this case. You can use it to tell pure and impure substances apart. Pure substances will have maybe just one spot, whereas impure will have multiple spots, maybe blue, red, green mixed together, whereas if it's pure, you will just have probably one spot. To also identify substances by comparing the patterns of known substances with unknown substances. I've already explained the example of police or forensic scientists using it to solve crimes. Then you can also identify substances by calculating their retention factor. We will look at how to work that out later. But if you have same substance used to do different things, say one pen used to sign a document in one bank and sign a document in another bank, if you work out the retention factor for both dyes or ink, you should get the same result. So that way you'll be able to know the person that did or carried out one crime committed the other crime as well. Police use it, like I said earlier. Now, what can we learn from this chromatogram? So interpreting chromatography paper or chromatogram. Now you can see here, brown is a mixture of purple and yellow dyes. So take a look, purple and yellow combine to make brown. Yellow and green are not mixtures, so you can see they have just one spot. So this is pure substance, this is pure substance. Purple is the least soluble. You can see it doesn't go, it only reach the middle of the paper. How is retention factor calculated? You just need the distance from the baseline to the spot divided by distance from the baseline to the solvent front. So the solvent front to the baseline and the distance traveled by the dye. It's just a ratio. So in this case, 0.5 divided by 4. Thank you very much.